Okay, so my whole class is laughing at me because we already tried to do this once. These are the answers from the practice sheet that we did yesterday in class. I told them, hey, I'm going to give you the answers. I'm not going to go over them because we did that yesterday in class. I helped anybody that had questions. You now have this review practice. What I'm teaching today will not be on the quiz tomorrow. Will not. As long as you use that practice sheet, you will be fine. Gracie. Okay. So I'm going to erase this. Hopefully you guys have this. If not, it's now on the video. Parents, good luck. I hope that you've been watching the videos because your kids might be smarter than you right now. Okay, here we go. Oh man, I'm really close. I'm really close. But my arm looked really good right there. Oh man. I felt buff. I didn't feel like 165 pounds. That was kind of fun. Oh man. Oh man. Okay. We are still in Unit 1. We are still doing exponents. We are on day 4, I believe, yes? So the last video said negative exponents and division, and then we only did division, okay? I didn't get as far as I thought I would, which is fine. Okay, so we readjusted. Today is just talking about negative exponents. Okay, today is just talking about negative exponents. Andy, can you do me a favor, sir? My water bottle's right back there. Can you grab that? Bring that up to me. Just hand it right here. You're the man, sir. Watch out, Elizabeth. Oh man, oh man, oh man, oh man. Okay. So, first and foremost, we're going to have a note. The note's going to say an expression is not simplified if there are any negative exponents. If there are any negative exponents at all, the problem is not done. It is not simplified. You cannot give me that as an answer. So just like on the quiz tomorrow where it says 3 to the 4th and it says simplify, you can't leave 3 to the 4th. You have to say 3 times 3 is 9, times 3 is 27, times 3 is 81. If you see something with a negative exponent, you are not done. Does everybody understand that? So, if you're like, hey, I've got the problem, it says 733x over y to the negative 2. No, we're not done. Okay? I want to make sure that you understand this takes a little bit of thinking. Okay? So let's start with this. The key to today is everything is a fraction. Everything is a fraction. We learned the other day that fraction means what mathematical operation? Bianca?
Division.
Division. So everything is a division problem today. Everything. We know how to divide, right? Okay. If I give you the number 7, I want you to make the number 7 into a division problem. And this was where I said, hey, I love that Mrs. Armstrong had a placeholder. What could we divide by 7 to show it as a fraction? So what did we do? Carly?
1.
Very good. It is 7 divided by 1. Anytime that all we have is one whole number, a variable is taking the place of a number, so it's just going to be a number. So we need to show that it's dividing by 1. What happens, though, if we have this variable? Let's say we've got y cubed. Can we show y to the third power, y cubed, can we show that as a fraction? What can we do to this to show it as a fraction? Good.
Can't you just put 1 over 1 cubed?
So you want 1 on the top or 1 in the denominator?
Denominator.
Very good. So y cubed will be in the numerator. Numerator is the top. Divided by 1. Sammy, that's fantastic. Okay? So we can divide those variables by 1. Okay, Maddie, you're going to help me. You ready?
Okay.
Let's say I've got x to the negative 1. No, not ooh. I still need to make it a division problem. I need to make it a fraction. What can I do to this to make it a fraction? What would I have to divide x to the negative 1 by?
Divided by 2?
Not by 2. Can somebody help her? Good. Yeah. We're still going to divide it by 1. Now my question is x to the negative 1 simplified?
No.
No. Because why? There's a negative what?
No.
Exponent. Listen, there's a difference between negative numbers and negative exponents. There can be negative numbers in my problem. There cannot be negative exponents in my problem. Still with me? Now, what is the only thing right here that has a negative exponent? What's the only thing that has a negative? Does the 1 have a negative exponent? No. It's 1 to the what? What power? First. So I'm going to put that. Everything has a power. What has a negative exponent? The x. So I'm going to change colors here. This x has a negative exponent. When something has a negative exponent, if it's in the top floor, it goes to the bottom floor. If it starts in the bottom floor, it goes to the top floor. And what happens when we flip it? A better word for flipping is the reciprocal. When we use the reciprocal of just this, it becomes positive. So I'm going to draw my fraction bar. I've still got 1 times x to the first. Why did it become positive? Because we used that reciprocal. What do we need up in the top now? Go ahead. Very good, Megan. A 1. Can I leave it like this? I could, but I can also simplify this a little bit. What's 1 times x to the first? Just x to the first. Now listen, Mrs. Armstrong said the other day, here's my favorite mistake. A lot of you were forgetting to just leave it there. It's a fraction. It's allowed to be a fraction. Some of you were just trying to say, it's x to the first. No, it's not. X to the negative 1 is not x to the first. It's 1 over x to the first. When we're dealing with negatives, let me start again. That was wrong. When we are dealing with negative exponents, we take it from whichever level it's at, switch its level, use the reciprocal, and make it positive. It's not hard. Okay, trust me on that. So let's take a look at another one. I love that I got so many different colors now. Makes my day. So let's do this. 1 over x to the negative 8. Here's the question I want you to ask yourself every time when you see negative exponents. Do I have a fraction? If I already have a fraction, do I need to try to do this? No, because there's already a division problem. Do I have a fraction?
Yes.
Yes. So now, just like we were doing with division, because this is a division problem. I'm going to draw my arrow. I make my fraction bar. Does everything have an exponent? Does everything have an exponent right now?
No.
Michaela, what doesn't have an exponent? The 1. So we make it with a 1. Does 1 to the first power have a negative exponent?
No.
So does it switch at all?
No.
If it has a positive exponent, it stays smack dab where it is. What do we do, though, with this negative? Brooklyn, what do you think we're going to do? Where is it right now? Is it in the numerator or the denominator? So where does it have to go if it's a negative exponent? So where do we have to move it from? The numerator.
Yes.
Okay, so we keep the base. What happens to my exponent when we move it? Good. It becomes positive. Well, what's going to be left over here? Because the x moved, so what's down there? What's our placeholder? 1. Is this how I want to leave it? Well, not really. What's 1 times x to the 8th?
X to the
I can leave it like this, or I can show it as x to the 8th over 1. Which would I prefer? I would prefer this first one. Okay? So you're going to try one for me. You're going to try one for me. I didn't want that. Drop that eraser. That was a bad one. So you can talk it over with the people around you, but I want you to try this one. Let's see what we got. Let's go. So here's example 3 for us. Let's go. So we've got x to the negative 7. Show me what you can do with that. Once you think you've got it, talk it over with the people around you. See what they've got. Okay, so what should be our first question we're asking ourselves? Go ahead. Yeah, is it a fraction? If it is not a fraction, what do we need to do, Maya? How are we going to change x to the negative 7th into a fraction? Because it needs to be a fraction.
1 under.
What do we call that under? Starts with a D. Very good. The denominator. X to the negative 7 stays in the numerator. The denominator is 1. Make sure everything has an exponent. Oh, man. Grego, what's missing an exponent right now?
1.
The 1. That's 1 to the first. Is that positive?
Yeah.
So are we going to move that?
No.
What are we going to move then?
The x to the negative 7.
Okay. Where does x to the negative 7 have to go?
To the denominator.
And what happens when it moves to the denominator?
It becomes positive.
Very good. Uh-oh, though. What's in the numerator?
A 1.
Very good, sir. A 1. Can I leave it like this? Not quite. What is 1 times x to the 7th?
X to the 7th.
This becomes 1 over x to the 7th. Still with me? Okay? So far as we were walking around, most of you had that, or at least had an idea of what you were doing. Does it become a little bit harder? Well, yeah. Not much, because nothing changes at this point. You're using the same properties. But let's try this. Let's go x to the fourth y to the negative third. So, you look at the problem and you say, okay, self, I see a negative. What do I need to say next? After I see that there's a negative, what do I need to ask myself? What do we need to ask ourselves? Is it a fraction? Simone, is this a fraction right now?
Nope.
No. So how am I going to make this into a fraction? What are we going to divide it by?
Put the row. What are we going to divide it by?
Yeah, what needs to be in the denominator?
The positive.
Not quite. You're on the right track. Brooklyn? A 1. To make it into a fraction, the denominator becomes 1. All of this stays in the numerator. And the all of this is x to the fourth, y to the negative 3. Now this is where it can get this much confusing. Ms. Graham, what's missing in exponent?
1.
The 1. It becomes 1 to the first. Do I have positive exponents? Do I?
Yes.
Swill, what are my bases with positive exponents? What's the base with a positive exponent in the numerator, in the top?
X.
The x to the fourth is positive. Do we need to move the positive exponent?
No.
No. What about 1 to the first? Do we need to move that?
No.
Okay. So now listen. I'm going to draw my fraction bar again. You've told me, and I'm going to circle it, because that helps me, usually, that this was my only negative exponent. So my first step now is to rewrite the positives where they go. Well, x to the fourth was in the top. Guess where it stays?
Top.
In the top. 1 to the first was in the denominator. It stays in the denominator. But I've got y to the negative third. Where does that go? Bianca?
And the denominator.
And it becomes what?
Positive.
So tell me exactly what I need to write.
Y to the third.
Very good. Y to the third power. Could I leave it like this? Sure. But do we need that 1? 1 times y to the third is just y to the third. Notice, and this is where my favorite mistake, most students would see this and change both of them to the denominator. No. We only move the negatives. I just pointed to positive. We only move the negative exponents. Still with me? Can we get a little bit trickier and have you try one? You can say no, it's not going to matter. I mean, you can just sit there and do nothing, which... Because I like to. I like to feel like I'm giving you a choice.
Even though you're not.
I'm not, no. Example 5. Here we go. Yes, sir.
Since we're doing the same thing,
Mm-hmm.
couldn't you just take it and move it to the opposite spot?
You absolutely could. If you don't need to show all of this work and you can go from here to here, do it. That's great. Okay? Here we go. You guys ready?
Yep.
Try it on your own. Try it on your own. Let's see what you got. So make sure you at least copy it down. Give it a try. I love that. Thank you. You're right.
Over here to the right, on the chalkboard part of this board, I put down the steps as I heard Mr. H giving them, so if you need to refer to this as you're working this out, go ahead, okay? If you need a little reminder of what process you take.
So I'm going to give you a hint, because some of you are struggling a little bit. Now that Mrs. Armstrong has it over there, let's pause real quick where you're at. Okay. Kendall, you ready? You ready?
Oh, my name's Kendall.
Oh man, that's a problem already. Help me. What's your name?
Caleb.
Caleb. Okay, Caleb. I did that yesterday too, didn't I? I'm sorry, buddy. Is there exponents on everything?
No.
So let's put them on. What's going to have an exponent? The y? What exponent is the y going to have? What else is missing an exponent? Somebody else. What else is missing an exponent? Let's get some new hands. Abby. The negative 3 has an exponent. What's the exponent on negative 3, Haley?
1.
What kind of one? Yeah, it's a positive one. Okay. So that's where we had the confusion. It's a positive 1. So now that everything has exponents, I draw my fraction bar. I will immediately put everything that has a positive exponent in the same exact place. KB, where does negative 3 to the first power go? Numerator or denominator?
Wouldn't stay.
Yeah. Why would it stay in the numerator, Brendan?
Because it doesn't have a negative exponent.
It doesn't have a negative exponent. Beautiful. Okay. What else is going to stay in the top, in the numerator? Garrett?
Y1.
Y to the first. Perfect, brother. Then I like to circle. Here's a negative. Here's a negative. So let's start with the numerator. We've already taken care of my positives. They've stayed where they're at. Where does x to the negative third power go? Come on, I need some more hands than the same. Sammy, go ahead.
X to the negative power of 3 would go in the denominator,
And become?
and x to the power of 3.
Positive power of 3. Very good. Okay. Alyssa, you ready? Where does z to the negative 2 go? Does it go to the numerator up top, or does it stay in the denominator?
The numerator.
The numerator. What happens to that negative 2?
It becomes positive.
Perfect. So oh, it becomes positive. Miss Rach is right, a negative. So here was the problem. You guys saw a negative 3 and said, it has to go to the bottom. Oh my goodness, it's negative. No. We're only concerned about negative exponents. Yes, ma'am.
I thought you said the problem wasn't done if there was a negative.
It's not done if there's a negative what? Exponent. If you go back and read that, it should say, it's not done if there's a negative exponent. Are there negative exponents? Then we are good. Okay? Can we try the next step of a problem? So, this is a problem that you may see down the road. Because remember, this is not on the quiz tomorrow. This is not on the quiz tomorrow. But, Maddie, have you seen the word simplify before?
Yes.
Yeah. That means, simplify means, we can only have one set of x's. So if I have x to the third times x to the fourth, my problem's not done. If it's x to the third divided by x to the fifth, my problem's not done. If we have exponents to the 0 power, my problem's not done. If we have a power with a number like 3 to the third, my problem's not done. Now, if we have negative exponents, my problem's not done. So I'm going to ask you to simplify this problem. Everybody with me? We're going to see how you do. This is going to be tougher. I'm going from step 1 to see who can jump straight to step 3. Okay, we might have to go back, but I want to see who my bright kiddos are. So we've got 3 squared. X to the negative 3 divided by x squared. Try to simplify it. Let's see what you can do. Okay? Mrs. Armstrong was very nice and wrote the rules over here. Is it a fraction? Are there negative exponents? Are there positive exponents? Positive exponents stay where they're at. Negative exponents go to the reciprocal location. So if they're in the denominator, they go to the numerator. If they're in the numerator, they go to the denominator and they lose the negative. Once you've done all that, then you have to simplify like what you're going to do tomorrow on the quiz. So the only new thing today is using those reciprocals. That's simplified, right? So on the quiz tomorrow, when it says simplified, you have to. Yeah, so you would have to do it anytime that it says simplified. B, what you doing?
I was waving to Maya.
I saw that. Is that simplified? Really? 3 to the second power is simplified? Can you combine those? Is there only one x? You've got 2 x's. Can you combine those?
Okay, now.
I know, but it's not 3 times 2.
Folks, I'm seeing a lot of good things happening right now. I'm seeing some things that we need to work on, but that's because it's brand new. But I'm seeing a lot of good things happening right now. Let's go with 30 more seconds. Talk to the people next to you.
Yeah.
No.
I just realized.
And back to me. Who feels confident they have the answer? Who feels confident they have the answer? Come on, I need some more hands in this. I know that I saw some. I didn't check yours, so I want you, even if you're wrong, I want you to shout out your answer. What do you have?
In the numerator, I have 9 and then x to the negative bit. Yeah. And then in the numerator, I have 1.
In the denominator?
I mean, denominator.
So that's your answer. Okay. Maya, you're closer than you think. Can anybody help Maya and say, hey, Maya, we need to fix something here? Sammy?
First, you have to take the x and negative 3 and move it down to the denominator to make it a positive.
Oh, Maya, do we want negative exponents?
Oh, no, I can't do that.
No, you didn't. You tried to group all the x's together by moving this x to the numerator, which isn't necessarily wrong because you grouped them great. But we can't have negative exponents. So let's go with our rules. Again, Mrs. Armstrong, she's fantastic. She put the rules over there. Is it a fraction? Well, yeah. You're welcome. What's positive? It stays. 3 squared stays. X squared stays. What's negative? I'm going to circle. And it has to move. It moves from the numerator to the denominator. And Maya, you use some great language. You were using numerator and denominator a lot. Once we're there, are we simplified?
No.
No, because we have a number to a power, and we've got 2 x's. So now, we need to say, okay, let's simplify the numerator. Swill, what is 3 squared? 9, because it's 3 times 3. Very good, sir. Now, when we move this x down here, x squared, x to the third, when we have variables next to each other, who remembers what operation it is? Show me with your fingers. Is it plus? Is it minus? I don't know how to do divide or times. What are we doing? Are we adding them? Are we multiplying? Or are we subtracting them? So I got a lot of different things. When there's a variable right next to another variable, it means multiplication. Mrs. Armstrong went over this, I think, yesterday with MLB and POTUB, power to a POTUB or something, power to a power, which is in parentheses, or combining like bases. These are like bases. So when we multiply like bases, we keep the base and we add the exponents. This is simplified. Yes, ma'am. So we're multiplying like bases. See how there's a multiplication? So when we multiply like bases, we keep the base, but we add the exponents. Okay, so the operation between the x squared and the x to the third is times, because what's happening here? So let's go expand it. X times x times x times x times x, right? That's what's really happening. That's expanded form. How many x's? Keep the base to the fifth power. Good?
Several of you were able to get, there are 3 different things we've learned this unit in that one problem.
Mm-hmm.
So several of you were able to apply at least one of those things, okay? But these are those type of problems where you have to look and put together all of those concepts that we've learned so far.
We're going to try another one like that. So we're going to simplify. So 2 to the negative 2 power, x to the 0, y to the 5th, you are simplifying. Probably be our last example for the day on the board.
I'm gonna give everybody a pause button right now. So hit the pause button. Pause. Come back to step 1. Okay? Come back to step 1 and look at that. Okay?
Always your first question once you see negatives, is it a fraction?
So, if it's not, your responsibility, this is part of the pause button, is to make it a fraction, okay? Think in your head, how do you do that? How would you make that expression a fraction? Go ahead and do that.
Okay, here we go. I saw a lot of great things. So, Mrs. Armstrong made you hit that pause button. Alyssa, what do we need to do first? What do we need to do first? Do the fraction bar. I'm going to do it right here. And put it over 1. 1 to the first power. Then we say, okay, everything that has a positive exponent stays where it's at. X to the 0 stays. Y to the 5th stays. 1 to the 1st stays. And I'm going to circle my 2 to the negative 2. It's in the numerator. Where does it go, Sammy?
It goes to the denominator.
Goes to the denominator and becomes positive. Now I can start simplifying. I don't have any negatives, so I can simplify. What is x to the 0 power? Anything to the 0 power. Michaela? 1. So now I've got 1 times y to the 5th. 1 to the 1st is 1. 2 squared is 4. So now I've got 1 times y to the 5th, which is just what? Y to the 5th. And I've got 1 times 4, which is 4. And that is that problem simplified. You do have homework. There are 8 questions on here. You are only doing 1 through 4. If you'd like to. You're only doing 1 through 4. Hey, quiz tomorrow.